Good afternoon, everyone. On behalf of agricultureinformation.com, I welcome Ms. Ankita Vijayvergiya, and she will speak on the topic 3-day precision food waste conversion to high efficacy bio inputs. I now request the speaker to begin. Thank you.
Well, thank you for the introduction. Hi, everybody, to everybody who's listening. I am from BillionCarbon, and at BillionCarbon, what we are doing currently is we are rebuilding the food soil loop through our technology, 3-day precision food waste treatment, which converts the food waste into soil regeneration bio inputs. So we have been recognized as top innovators by the World Economic Forum, by BRICS in Russia, as winners of the Startup India Grand Challenge of Food Processing, by MOFP, where we were awarded by Honorable Minister Shri Chirag Paswan himself, and as winners of several competitions from United Nations. This is the founding team led by me. We have 50 plus years of experience in building and scaling global ventures. We are alumni of London Business School, and all of us are BITS Pilani engineers. We also have a strong team of research scientists, advisory panel, and ground staff solving for this problem with us. So 4.5 billion years of evolution perfected the food soil loop. Nature in this entire evolutionary history has perfected a loop in which food returns to soil and the nutrients get recycled where soil regenerates food itself. However, in just 150 years of industrialization, humanity has broken this loop to create a linear food supply chain. It's an extractive chain, food supply chain as we call it, where nutrients are lost, soil becomes chemical input dependent, and food waste ends up in landfills. Now, the problem is huge. 60 billion kgs of food waste is dumped into India's landfills on an everyday basis. This also releases a lot of methane and is responsible for a large chunk of the global warming and climate change emissions that we are seeing right now. Also, this means that the nutrients from the food waste are lost to the landfill forever. On the other hand, 40% of global soils are now degraded, driven by chemical-dependent agriculture. What this means is that there are lower yields and the world's food security is at risk. This also means that smallholder farmers specifically, they're trapped in a circle of rising costs and declining yield systems, because the more chemical inputs you put in, the worse your soil is actually becoming. Now, due to this, the chemical inputs, farmer cancer cases are also very rampant, especially in northern India, especially in Punjab, as we see, where a lot of farmer cancer is happening because of rampant use of chemical fertilizers and chemical inputs, especially in paddy farmers. Now, fixing this food soil loop is not a very complicated thing. A systemic approach can lead to fixing all three things together: agriculture, landfills, and methane. And that is what we are working towards. And this is not just a big problem. It's a $300 billion global opportunity along the food supply chain. What we are seeing is that existing solutions of the nutrient recovery from food waste, they're consistently failing. Why? Composting is slow. It takes large land areas. Machines like organic waste composter machines or biogas plants, they are costly to set up and costly to run. And they produce dirty sludge as an output, not fertilizers. And so what we saw was that the existing technologies, conventional solutions, have been failing and they are unscalable, especially at a national and a global scale. Hence, 3 years ago, we went back to the drawing board, rethinking this problem of how to solve it using science and engineering. We first went back to nature. We studied digestion and solid state fermentation as it happens in nature. Just like humans eat and digest the food and excrete the next day, just like that. We ran thousands of controlled experiments on hundreds of variations of food waste substrate and organisms. And we have developed a consortium of micro and macroorganisms with scientists. Just a second, hold on. Yeah, sorry about that. So like I was mentioning, we went back to learn from nature. We developed a consortium of micro and macroorganisms with scientists, which could actually work for the urban environments of food waste. The next step was the industrial engineering, the next part of the technology. The first part is the biology. The second part is the industrial engineering. Here, we designed and created a 4-chamber bioreactor, which can turn this biology into a reliable and repeatable machine. We basically engineered for two things: the speed of conversion and the cost of conversion. Now, this bioreactor is a 4-chamber bioreactor, which can accelerate the natural processes without using any electricity. And this is our innovation, a 3-day precision tech for conversion of food waste into soil regeneration bioinputs. What we have created is a unique aerobic solution which calibrates process, ingredients, and technology, and is able to concentrate all the nutrients from the food waste into high efficacy bioinputs. Now, the thing to remember here is that we are able to achieve up to 95% biomass reduction in food waste volume in 3 days or less. This is unheard of in the industry. The entire technology is powered by a consortium of micro and macroorganisms and the self-regulating bioreactors as the engineering input. Now, the fact that the biomass reduction is so high, it means that the remaining 5% of the outputs that are left are high concentrations of nutrients, as compared to if you see other outputs like sludge and all, they're very nutrient low. Here, what we have produced is a high density nutrient fertilizers. Now, what this means is that the cost of transportation and the cost of application both reduce for farmers. Needless to say, we have applied for a patent for the same. Now, food waste essentially is turning into income for farmers. These organic bioinputs, there are 2 bioinputs that we create. One is the liquid biostimulant, and the other is a solid frass compost. Both of these are capable of replacing chemicals, reducing costs, and increasing yields for farmers. We are backed by the government of India through various schemes: Raftar, RKBY, MOFP, DSD, Srujan, Swachh Bharat Mission. And what we have seen is that in the initial field trials, both of these fertilizers are giving spectacular results. The liquid biostimulant, especially, we have seen up to 24% yield increase in initial field trials, and this is compared to chemicals, not a control group. We are currently incubated at the Anand Agricultural University for conducting advanced field trials, so we can take both of these products to market and commercialize them. If I were to just give you a quick view of what these both are, the liquid biostimulant is a micronutrient-rich liquid with NPK mobilizing bacteria that improve nutrient uptake. The solid frass compost is something that improves soil carbon and soil structure at the same time. And it is extremely important for long-term fertility. Now, in 2024, we went to market with our solution and pilots and early field trials, etc. And what we have seen is that now operations are stabilized and In 2024, we saw a lot of feedback from the market and we streamlined everything so that we are able to make repeatable operations and repeatable conversion to bio inputs in real world situations, not just the lab and not just the field trials. Because we are all engineers, everything is backed by data, and we have infused live data intelligence into the precision conversion system. In 2025, we also went out to validate the impact with farmers through field trials. So far, we have impacted more than 1,200 farmers across India, and the crops that we have tested on are tea, garlic, onion, corn, cauliflower, wheat, papaya, tomato, beans, and more. What we have seen is that some results have been qualitative, of course, and some are quantitative in nature as well. Now, the qualitative results are that there has been reduced disease and pests, especially reduced rot, blight, leaf rust, etc. Quantitatively, something that we have been able to do with tea is that we have seen up to 24% yield increase. This is due to growth promotion, due to firmer stems that have been coming out, more leaves, increased size of the leaf as well, and the quantity and the quality of both kinds of produce. Also, we have seen some initial results on the soil health improvement, more moisture retention, more soil organic carbon increase, and increased microbial biomass and activity, which leads to long-term soil health, long-term soil fertility, and the possibility for that particular farmer to reduce the chemical usage because the soil health is so much better. Now in 2025, we are proud to say that we have transformed food waste conversion to bio inputs for the entire industry. This earlier was a slow, dirty, costly, and unscalable system. And now we have transformed it into a clean, circular, and scalable new age solution. I want to highlight the impact we have had so far. 4 million kgs of food waste processed scientifically, 2 million kgs of carbon dioxide equivalent mitigated, and we maintain a 50% women workforce. And an impact that we did not expect. It completely transformed worker health. Now, we all know that the condition of waste workers across the world is quite abysmal. But here is a testimonial from one of our sites. It doesn't feel like working in a waste treatment site. Earlier, I used to have 3 to 4 sick days per month. Now it is 0. This was huge for us. This was a huge validation that the direction we are going in is the right one. So far, in our work of driving farmer income, worker dignity, and community health, we have been able to benefit more than 4,000 low-income beneficiaries, which includes smallholder farmers, waste workers, and communities which don't have access to such resilient food systems. Our business model is quite simple. We currently work with bulk waste generators who produce food waste on their sites, and we provide a fully managed subscription service for the food waste treatment for them. Now, the operations are compact, which also means that there is a lot of land that is freed up for them. And because we provide a full service model, this means that there are no breakdowns, and it is a zero hassle system for the client. The scale at which we operate on can range from 100 kgs of food waste per day to 10 tons of food waste per day being converted into bio inputs. Now, quick view of how it actually works on the ground. After we set up a site on the client premises, what the client really needs to do is just shred and load the waste daily. This is done by their labor. And then the auto process kicks in, which inside the self-regulating bioreactors. It's a completely aerobic process. The third step is where the outputs need to be harvested periodically. The liquid biostimulant is to be harvested once in a week, and the solid frass compost is to be harvested only once in a month. That is how easy and scalable we have made the operations. If you compare it to something like an organic waste composter machine, the sludge output has to be handled on a daily basis. And the volume of the sludge is so huge that it really becomes unhandleable. The nutrient content of the sludge is so low that no farmer is ready to take it as an offtake. We have just flipped all of that around with our solution, with our technology, where the outputs are concentrated and they need to be harvested only periodically. So that reduces the operations, that reduces the cost. And if the cost is reduced of production, then the cost to the farmer is also reduced for the inputs. Plus, these are high efficacy bio inputs because they are so concentrated in nature and they're made through a completely natural process. The fourth step is where the bio inputs are processed, distributed, and adopted for field trials currently with farmers. Currently, they are not commercially available. So essentially, what I want to highlight here is that this is how we are closing the loop of food waste, returning those nutrients from the food waste to farms where our food is growing and coming back into the loop back again. So a little bit more view on what the circular organic bio inputs are. We talked about this a little earlier, but the liquid biostimulant and the solid frass compost, these are the two inputs that are being produced. The liquid biostimulant is a microbial liquid, which also has organic carbon and is rich in humic and fulvic acids and live NPK mobilizing bacteria. The solid frass compost, on the other hand, is a nutrient-dense, stabilized frass compost. It has high biological activity and is completely stabilized, odor-free, and very low in volume. What this helps with is transportation costs are majorly reduced. Now, both of these work for improving soil health, replacing chemicals, increasing nutrient uptake, increasing the stress tolerance of the plants, and increasing the yield, of course, as a result of all of this. Essentially, all in all, if I were to sum it up, both of these are micronutrient-rich organic alternatives to chemical additives. And that is extremely powerful. We are enabling the transition to organic urban landscapes and regenerative agriculture by taking in the food waste, which would otherwise go to landfills. We are currently present in 3 cities, Ahmedabad, Mumbai, and Pune. Our field trials happen across several states in India. And very soon, we are also going to be live in 5 other cities, Delhi, Hyderabad, Bangalore, Chennai, and Kolkata over the next few months. We started with a broken loop. Food was going to waste and soil was becoming chemical input dependent. And in that entire process, nutrients were being lost. We at BillionCarbon, we are rebuilding the food soil loop and in turn, decarbonizing the circular food ecosystems and their creation. We are fortunate enough to have global believers back us in our mission, and this is our dream. This is also why we call ourselves BillionCarbon. We want to empower 1 billion tons of carbon dioxide equivalent mitigation and generate 100,000 climate jobs by 2030. Thank you.
Thank you very much, ma'am, for a wonderful presentation. I'll take up the questions now. In the meantime, can you please stop sharing the screen so that we can see your full video? Yeah, I'll move on to the questions now. The first question is, what are the major challenges in handling mixed food waste from hotels, campuses, and commercial kitchens?
Several major challenges. I think the first is whether the food waste that is being brought to us, is it segregated or not? So as a policy, we do not accept food waste that is not segregated, because also as per Government of India mandates, all bulk waste generators need to be segregating their food waste. So that is one. The second is high liquid content of the food waste. Now, for that, we have processes in place through which we are able to process even the high liquid quantity of food waste as well. But that has been a journey of technological innovation for us, which now we can confidently say that we are able to handle very well for our clients. The third is the variability of the food waste. So when we set up the systems, we set up a certain capacity. Now, that capacity, let's say if it is 1 ton per day, what we have now done is we have modified and we have evolved our systems to such an extent that we can handle even 100% variability of food waste, which means that if on a certain day, zero food waste is coming in, our processes and systems would still be running, which is not the case with biogas plants, for example. If a 1 ton per day biogas plant is set up, every day it needs segregated 1 ton of food waste. Otherwise, the pressure will not be built, and then the process would need a lot of maintenance for that. So several of these challenges, of course, there are many more, but yeah.
Okay. How do we ensure that the final bio inputs maintain high nutrient quality and consistency?
So what we have seen is that different kinds of food waste substrates, when they go in, they produce different kinds of bio inputs, right? And those different kinds of bio inputs are useful in different types of settings. For example, agriculture, certain types of crops, or urban landscaping, or even if we are talking about agriculture, even different regions require different kinds of micronutrients to go into the crop. Now, how we ensure it is we are creating standardized processes through which the food waste that goes in is standardized. That is one. Secondly, whatever bio inputs are produced, we make sure that at the end of it, we are standardizing them and productizing them, so that we run, to do that, just to take a step back, to do that, we run tests on every batch, multiple tests on every batch of the fertilizers that are being produced. And based on that, the fertilizers are homogenized, standardized, and then sent to field trials. So yeah.
Okay. Many composting systems face issues like odor, sludge, and pest infestations. How
Yes.
has BillionCarbon addressed these operational problems?
Yeah. So those are the major innovations that we have done. One is we have containerized the entire process, right? So a lot of this is now happening in a very controlled environment inside the bioreactor. So a lot of the problems automatically get solved. Also, we treat fresh food waste. What that means is that food waste is treated on the day it is generated. It's not left to rot for 1 week and then it is put into a conventional system for treating. That's not the case with us. We have designed our system to be so efficient that food waste, the day it is brought in, it is treated on the same day. That means that there is no odor due to food waste lying around and rotting, which also means that pests are not attracted in the first place. And that also means that our operations are very streamlined to be able to contain all of these problems, which are usually found and which are difficult to handle for conventional systems like OWC machines. Now, in terms of sludge production, like I mentioned in my presentation as well, the main problem with OWC machines and biogas is the sludge that is produced at the end of the entire process. We have turned it around completely on its head. What we produce is high efficacy bio inputs, and how we ensure that it is high efficacy is by maintaining the high biomass reduction amount. For our case, it is 95% biomass reduction. For something like composting or OWC machines or biogas, it is only 50% biomass reduction. What that means practically is that if you're putting in 100 kgs of food waste, out of it, at the end of the day, you will still get 50 kgs of sludge every day that will need to be handled when it comes to OWC machines and biogas. However, with our system, that 100 kgs of food waste will be converted to just 5 kgs of highly nutritious and compact fertilizers. And these have to be operated and handled only once in a month. That is the innovation.
Okay, your system claims to work without electricity for the core process. Could you explain the science behind this low energy approach?
Yes, absolutely. So nature has all the intelligence. We just need to go and find out what is it that we can adapt for ourselves for the urban environment. And that's exactly what we did. What we did was we started with a hypothesis of what kind of microbial and macroorganisms consortium can work the best for treatment of the food waste in an urban setting, especially the kind of food waste that urban settings generate. And then we ran thousands of controlled experiments on that. We looked at hundreds of variations of food waste substrate versus the organisms that we were using, and what combinations of those were producing the best results. Now, there are two parts to the technology. One is the biology itself. Like we mentioned earlier, we went back to study digestion and solid state fermentation, just like it happens in nature. Just like humans eat and we digest the food and we excrete the next day, that's a single day process. It does not require any electricity. It uses entirely biological energy, which is already present in nature. That is the exact process that we have emulated here. Then what we have done is the second part of the technology, which is the industrial engineering part, where we have created and designed a self-regulating 4-chamber bioreactor, which can run without electricity and can accelerate the conditions, maintain the conditions, which can accelerate the natural processes that we just spoke about. And that is the entire science that goes behind this entire technology.
Okay. How can this technology help Indian cities reduce landfill dependency and methane emissions?
Very good question. And that is exactly why we have created this technology, because what we have seen is that Indian cities are producing waste, and there is no viable way to handle that waste. Hence, everything really ends up in the landfills, even if it is very probable that it is ending up in landfills. Now, what we have done is we have created a technology which can be deployed on site for our clients, which is a mandate as per the latest solid waste management rules for bulk waste generators. Now, the main problems with deploying on site for clients that they have been facing before us was the lack of space. That's one. Second is operational hazards and operational heaviness of whatever has been done in terms of, let's say, OWC machines or biogas. The third is the cost. What we have done is all these three factors we have brought down to such an extent that it becomes a no-brainer for the client to adopt our solution. And then we are able to set up this technology on their sites of food waste conversion to bio inputs, where they can use the bio inputs in-house. They are able to use it. We give them the technology and the operations required to use it. And where they can't, we off-take it and we take it to our field trials, which are happening across several places.
Okay, how suitable is this model for rural India and decentralized waste management systems?
So rural India has different kinds of constraints. rural India, one, it does not produce that kind of waste, which urban India produces. So urban India produces a lot of kitchen waste, a lot of dal, sambar, a lot of rice, rotis, etc. In rural India, the major food waste that is produced is agriculture waste, because whatever is produced in the kitchen, if that goes to waste, then it really ends up in an animal's stomach, right? Either a cow or a dog, etc. So the challenges faced in rural India are much different than what are the challenges being faced in urban India. The technology can very well be adopted in a rural setting as well, simply because of the way we have designed it, of the way we have made the operation so simple that all that needs to be done on an everyday basis is just take the food waste, shred it, put it into the bioreactor, and then at the end of the month, you will get very nutrient rich solid frass compost and liquid biostimulant that you can utilize directly in your agricultural fields.
Okay. What types of bio inputs are produced from the process and how effective are they compared to conventional fertilizers?
Yeah, so we spoke about it. I will just highlight it again. The bio inputs that are produced are two kinds. One is a liquid biostimulant, the other is a solid frass compost. Now, both of these are very high in nutrition content, exactly what the plant needs. For example, the liquid biostimulant is very high in NPK mobilizing bacteria and humic and fulvic acids. Now, the combination of these two is very powerful. Why? Because it is able to facilitate growth promotion in the plant through the humic and fulvic acids, and it is able to facilitate soil regeneration through the microbial content that it has. Similarly, the solid frass compost has a lot of organic carbon in it. And what it is able to do is when applied on the soil, it is able to slowly stabilize the soil's structure and soil's carbon and make it much better. What it also does is increase the moisture retention of the soil, which in turn automatically increases the yield of the plants. So, yeah.
Okay. How do government policies and waste management regulations influence the adoption of such technology in India?
Sorry, say that again.
How do government policies and waste management regulations influence the adoption of such technologies in India?
They influence it a lot, especially with the latest solid waste management 2026 rules. Bulk waste generators are mandated to treat their food waste on site starting 1st April 2026. Now, in light of this, we have now started to get a lot of demand of our technology being deployed in the urban settings. So policy is a huge driver. If policy wasn't there, if Swachh Bharat Mission wasn't there, if solid waste management wasn't there, we wouldn't be here creating this technology and deploying it on the field. So it is a huge driver of innovation.
Okay. What advice would you give to young entrepreneurs who want to build impactful business in sustainability and climate innovation?
Well, a lot of advice, but I think the top ones would be okay, a couple of things. One is climate change is going to be one of the biggest problems that humanity faces over the next 10 years, over the next decade. Hence, I would urge everybody to consider either working in climate or solving a problem that solves for climate change. Now, working in climate does not mean that you need to go to an NGO or you need to go to a climate tech company and work for them. It can also be that your current job becomes a climate job by you considering everything that you're doing in your job and considering what impact it has on climate, on the environment, on water, etc. And how can you mitigate that impact as a company? Because if you are the decision maker in your company, then you have a lot of say in how you are defining the direction of your company when it comes to their net zero goals and when it comes to their climate action. So that is one. Second is, when you find a problem, be loyal to the problem, not to the solution. When we started working in climate, we didn't know what we wanted to do. So we started researching on several problems in climate, and what we found would be the most impactful was food waste. And that is the reason why we started looking at how do we solve for food waste such that it becomes a scalable problem and a globally scalable problem, globally scalable solution at that, right? And that is how we eventually looked at all the current solutions that are there, what we can adopt, what we need to ignore, and what we need to innovate on so that it becomes scalable in the way that we want it to. So stay loyal to the problem and not to the solution. The problem that we set out to solve was how do we treat food waste at scale? And that is what we are doing. The third and the final thing is perseverance for any entrepreneur. Look at success as a validation and look at failure as another validation that you now know that this direction is not going to work, right? So as an entrepreneur, you will have to take hundreds of decisions every week. Not all of them are going to be the right decisions, but you need to figure out which ones are going to help you learn to take the next step, which will then be a success. So perseverance is the third advice that I would give.
Thank you very much, ma'am. We have now completed the round of questions. On behalf of agricultureinformation.com, we would like to thank Ms. Ankita for the talk and for answering the questions. This meeting will now be closed.
Thank you so much. Thank you.
Welcome.